go ahead and move on. As we further through the complex number system, we also need to talk about day 2, simplifying complex expressions. Okay, back then in Math 1, you were looking at radicals such as the square root of 16 and the square root of 48. And also you may have added or simplified radicals such as the square root of 75 plus the square root of 27. So those rules still apply, and that's fair game to what you're about to learn, or about to extend them to, really. Okay? We know that in order to simplify a radical, first, you want to list all of your perfect squares. So 1 times 1 is 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. But you don't stop at 10 because now we're in high school. We're in Math 2. So let's go 11 times 11, 12 times 12, 13 times 13, 14 times 14, 15 times 15. You can even go to 16 times 16, which is 256. Okay, and you can continue. I do urge you to go down all the way down to 625. Okay, that's 25 times 25. Okay, so we're trying to find out the square root of 16. Well, first and foremost, you know that the square root of 16 is 4 because that's a perfect square. So we lucked out with that. But if you have something that really isn't a perfect square, look at your list of perfect squares that we just wrote and find the largest perfect square that can go into that number evenly. Okay, we want to find the largest perfect square that would go into that number evenly. That way we have less problems reducing or trying to reduce. Okay? So let's experiment with our next number, the square root of 48. Well, if I break down the square root of 48, all right, let's use the largest perfect square that goes into 48. That means we have 16 and 3. So we need to take the square root of 16 and the square root of 3. Well, as before, we know that the square root of 16 is 4. Do we know what the square root of 3 is? We really don't. So, because we don't know what the square root of 3 is, and it's an irrational number, we just want to write it next to it. And there goes our simplified form. 4 times the square root of 3. Same thing here with 75. Take the largest perfect square that can go into 75 evenly. All right, so we have 25 times 3. Make sure you take the square root of both of them. All right, and the square root of 25 is 5. We don't know the square root of 3, so we're going to leave that. But we need to do the same thing here with 27. We want to take the largest perfect square that goes into 27. Let's try 9 times 3. So take the square root of 9, square root of 3. The square root of 9 is 3. The square root of 3, well, we don't really know. So we just want to leave it and put it next to each other. Now that we have simplified both radical expressions, we want to go ahead and bring down this plus sign so that we can perform our indicated operation. Okay? Because we have like terms, such as the square root of 3, we know that our answers are going to have the square root of 3. Well, with that being said, we just need to perform the operation between the coefficients. So 5 plus 3 gives you 8. And your answer is 8 times the square root of 3. Okay. Well, that was then. This is now. All right. The only difference with now is back then, you were told that you could not take the square root of a negative number. And that's true if we're looking at the set of real numbers, okay? Hence the real number system. But now we're in the complex number system. In order to take the square root of a negative number, we had to go through a different number system to work this out, or simply be able to simplify this expression. And now we can, okay? The only difference is you just have this negative in front of here. So you can go back and start by taking the negative out. So we know that 16 times negative 1 gives you negative 16. Well, let's take the square root of both of them. All right, we know the square root of 16, again, is 4. What's the square root of negative 1? Well, by definition, that's I. So our answer is 4I. Yeah, I know it's a little tricky, but something that you got to work with and practice on. Okay, because that's going to come up in quadratic equations pretty soon. All right, again, the square root of negative 48. Well, let's break it down. Let's take out that negative 1 first. So we know 48 times negative 1 gives us negative 48. All right, we need to take the square root of 48 and the square root of negative 1. Well, we got to go back and break down 48 first into a perfect square and another number. So that's 16 and 3. Now take the square root of 16 and the square root of 3. The square root of 16 is 4. Okay. We have the square root of 3 there that we don't know. And now the square root of negative 1 again is I. So we got to bring this all together. All right. This will be written and seen as 4I times the square root of 3. Okay. Notice that I brought the I in between the 4 and the square root of 3 here. Okay. That's there because that's how you're going to see it usually. You want to definitely make sure that the I is next to the coefficient if possible, and not the radical, not behind the radical. All right. Here we go again. The square root of 75. We said the square root of 75 gave us the square root of 25 times the square root of 3. So that was 5 times the square root of 3. And if we break down this negative 27, that gives us 27 times negative 1. Well, let's take the square root of 27. The square root of 27 times square root of negative 1. Well, we got to break that 27 down again, just as we did before, into a perfect square of such. So that's 9 times 3. Let's take the square root of 9 and the square root of 3. So 3 times the square root of 3. And don't forget, you have this negative 1 here, so that's an I. So let's rewrite all of this into an expression that we can see. So you have 5 times the square root of 3 plus 3I times the square root of 3. All right. Notice that 5 times the square root of 3 does not have the same terms as 3I times the square root of 3, so we can't combine them. That's our final answer. Okay. One thing to remember out of a lot of things, but this is one thing that's really important. When we're talking about radicals, and that's what we're going to be talking about throughout the duration of from now to for winter break, when you have A, when we're taking the square root of A and we're multiplying it times the square root of B, it's just so much easier and simpler for us to multiply them first and then talk about the square root of it. You can do that so that you have less problems later on in the end. That's just one way of thinking of it. It's not always the best way, but it's one way of thinking of it so you don't have too many problems. It definitely solves a lot of problems and simplifies them much quicker as opposed to trying to figure out the square root of the first number and multiply it times the square root of the second number. And you'll see that in an example coming up. So make sure you write that down. All right, also, when you're dividing here, when I have the square root of A divided by the square root of B, let's try to make sure we put that as a fraction with the square root sign on the outside. Okay? Because sometimes, again, it's much easier to reduce the fraction first and then take the square root of it as opposed to trying to do it individually. And again, this is just sometimes, but it's just something good for you to remember in practice. All right. So today, we practiced the even problems only. So the even problems that we were looking at were 12, 14, 18, 20, 24, and 26. Okay? And we practice those in partners. That way we can get used to seeing the negative under the square root sign. So negative, number 12. You have 4 times the square root of negative 7. All right? Not much you can do here other than bring out that negative. All right? So you have 4 times the square root of 7 times the square root of negative 1. Well, what's the square root of negative 1? By definition, it's I. So as we're rewriting this, you're going to have 4I times the square root of 7 as your answer. Okay. Number 14 here for you. A lot of us probably struggle with this, but again, you can do this one of two ways, and you'll still get the right answer. So you have the square root of negative 50 and square it. Now, some of us saw it as this. Some of us said, well, okay, if I take the square root of negative 50 and I multiply it times the square root of negative 50, I'm going to get a big number. And that's right. And that's fine. However, remember your square root property. If I am squaring something that's being square rooted, my answer is just what's under the square root to begin with. Why are we doing so much work? Don't do more work than you need to. So the answer was negative 50. All right, number 18. So you have 4x times the square root of negative x. Again, let's rewrite it as 4x times the square root of x times the square root of negative 1. We know that by definition, the square root of negative 1 is just I. So we're going to rewrite it as 4xi times the square root of x. And you're done. Okay. Number 20. Number 20 says the square root of negative 2 times the square root of 8. All right. Again, if you remember, if you looked at the remember that we talked about before you did this, it says when I have the square root of a times the square root of b, just rewrite it as a times b. So you have the square root of negative 2, which is your a, times the 8. Well, we know that the square root of we know that negative 2 times 8 is negative 16. So you're looking at the square root of negative 16. Now let's break that down. Okay, so you have the square root of 16 times the square root of negative 1. Remember, the square root of negative 1 is what? It's I. What's the square root of 16? 4. So the answer is 4i. Okay, so that's number 20. Moving on. Question 24. You have the square root of negative 24 over the square root of 3. Again, if we use the definition that we talked about, the square root of a divided by the square root of b, let's go ahead and bring it under one umbrella. So that's going to be the square root of negative 24 over 3. Okay? We know that 3 goes into 24 how many times? That's 8 times. And a negative divided by a positive is negative. So we're really simplifying the square root of negative 8. So let's do that. So we have the square root of 8 times the square root of negative 1. We know that the square root of negative 1 is just I, so cross it out. But we have to do some work with the square root of 8. What two numbers can I multiply together to get 8? And one of them has to be a perfect square. So we want to break it down to 4 and 2. Well, the square root of 4 is 2, and the square root of 2, well, we don't really know. So we just want to bring it down. Let's just remember to rewrite it. 2I times the square root of 2. That's how you're going to see it written on the test if it's multiple choice. And that's the expectation. All right. Number 26, you have 11 times the square root of negative 6 over 11 times the square root of 2. All right. The first thing I would do as a math student, if I see 11 in my numerator and 11 in my denominator, I probably would cancel those out because 11 divided by 11 is 1. So I would start by rewriting that first. So what I'm really looking at is the square root of negative 6 over the square root of 2. Again, by the principles and the properties that we got before we started this, we said that we will take this and write it as a fraction, a single fraction under the square root. So that's the square root of negative 6 divided by 2. Well, can 2 go in as negative 6 evenly? It sure can. That gives us the square root of negative 3. Okay? So let's break it out. You have the square root of 3 times the square root of negative 1. What's the value of negative 1, the square root of negative 1? That's I. All right? We can't do nothing with the square root of 3, so we just write it as I times the square root of 3. And there goes the answer. Again, there are many practice problems on this. I do urge you to continue to practice with these problems and definitely work it out. It's only going to take practice and it takes time.